Hello everyone, today's lesson is on energy. Energy is defined in physics as the ability to do work. And the thing is that last time we did work, we studied work, force times the distance was going to give us work. But what it's important to understand is that a change in energy is also equal to work. Work is equal to a change in energy. What does that mean? If a body does work on an object, for example, I push a chair on the floor, then the body doing the work loses energy. So my body is expending energy in order to push the chair. And the object that I'm putting the work towards gains that energy, okay? So what does that mean? That object is actually doing work. So in that case, the chair will glide across the floor. So in terms of formulas, what we can say is that work is equal to a change in energy, or a change in energy is equal to work. We can say it both ways depending on who's doing the work. So here's I'm doing the work and the chair is going to get that energy, or the energy that my body is using to do the work is going to end up being the work being done by the chair, the movement that the chair is doing, okay? Now, and we can see that these guys are equivalent, they're equal to one another because the measure for work is joules, and we also measure energy in joules. Those are exactly the same units, okay? So for that then, we're going to see that we're going to be able to use some formulas and do some calculations in just about a second. But the first thing I want to do is I want to look at different kinds of energy, because if we're going to be discussing energy, we have to see that there is many different forms of it. So for example, chemical energy. Chemical energy can also be called chemical potential energy. Because this is the energy that is stored in the bonds of compounds. For example, a plant will take in sunlight through photosynthesis and will use that energy that is getting from the sun to make the bonds that form carbohydrates, that form sugars. And sugars are very large substances, very large chemicals with lots of bonds, and therefore lots of stored potential energy. And then when my body ingests the sugars, what it does is it uses a digestive system to systematically break those bonds. So one by one, those bonds are being broken by my digestive system, and every time those bonds are being broken, energy is being released. And that energy is then used to fuel my cells to be able to do work. Okay, so that energy is stored in the bonds between the compounds. Electrical energy, so electrical energy, this is the work that is done by moving electrons. Okay, so we have a flow of electrons from an area that has a surplus of electrons in a battery, for example, known as a cathode, to an area that has very little missing electrons, an anode. And so what you're going to have is you're going to have a flow of electrons from an area that has lots to an area that has little, and that flow of electrons within a circuit is going to create energy, and that energy can then be used to power appliances, lights, all sorts of different mechanisms. Nuclear energy, this is energy that is stored. So again, it's a potential energy, but this time it is in the nucleus of an atom. And so we know we can have different kinds of nuclear energy. There is the fission. Fission means to split. So we know that splitting in the atoms will release energy for the same reason as the splitting of bonds. So we have that energy that can be released. And then we have also the fusion. Fusion means to combine. So firing atoms at one another can cause them to fuse together, and when they combine, they can also release energy. So that's nuclear energy. And probably the most important for our life is solar energy. And so solar energy, this is the energy released by the sun. And the reason why the sun is releasing this energy, is producing this energy, is actually there are nuclear reactions going on in the sun. So nuclear energy inside of the sun, and it's actually fusion that is happening inside of the sun that is causing it to release that high amount of energy. And obviously, that energy is way too powerful for us to have directly. And so what we do get from the sun, what we do benefit from, is the one that we get from the electromagnetic spectrum. So if we were to go electromagnetic, you probably recognize the electromagnetic spectrum right here. And so we're gonna, whoops. There we go. We're gonna put it on there so you can see it. Okay. And so we can see here that we have from sort of a high frequency to low frequency energy. And we have increasing wavelength and decreasing wavelength, and then increasing that energy. And so the higher energy are going to be the gamma rays, the X-rays, and the UV rays. These guys are all dangerous to living organisms, and so thank goodness that we do have an ozone layer. And we also have the electromagnetic field of the Earth that gets rid of these kinds of rays that are coming through. If you've ever seen the northern lights in the northern hemisphere, that has to do with the Earth's electromagnetic field that is sort of reflecting away these gamma, X-ray, and ultraviolet rays. And as they are sort of, and we call that, these have a common name called solar wind. And so when these things are being deflected away, what we see is sort of the movement of those particles that have been energized by these rays, and we see those as the northern lights. Okay, the visible light, this is the spectrum that we see, the rainbow of colors. And then we have infrared, so this is heat. Microwaves and radio waves, these are not perceptible by us, but again, they are hitting the earth and having an effect on living organisms all the time. Okay? And then we have thermal. And thermal energy, this thermal energy is energy that is generated by the movement of atoms. The friction of atoms with one another will generate heat. Lots of friction means lots of heat. So you will find that, for example, in the middle of the earth, in the crust, where you have the molten lava, is because of a great amount of energy generated by those atoms is going to result in a great amount of thermal energy. Okay. And the last one, and the one that we're going to be focusing a little bit more in this section of physics, is going to be mechanical energy. So mechanical energy, this is the energy possessed by objects, either because of their motion. So it can be kinetic energy. So I'm sure you've heard of kinetic energy before. So that's another kind of energy we should be paying attention to. So I'm just going to underline it in green. Or because of their position. So we call this potential energy. And you can have gravitational potential energy. So when you hold an object high up above the ground, it gains gravitational potential energy because of its position. If I have an object that can stretch like an elastic, I can talk about elastic potential energy, for example. Or if I'm looking at bonds between atoms, I can say that we have chemical potential energy. Okay. So when it comes to mechanical energy, I can say EM for mechanical energy. That's a combination of both, sometimes the kinetic and potential energy. And so kinetic energy is EK, potential energy is EP. Okay. And again, so kinetic energy is energy for a moving object, and potential can take different forms depending on what I'm dealing with. Now back to what we were talking about then here, when we said that work is equal to a change in energy. The reason why that formula becomes so important, because that's known as the law of conservation of energy. So the law of conservation of energy. This is also known as the first law of thermodynamics. So the law of conservation of energy states that energy, and I'm sure you've heard of this one before, cannot be created nor destroyed. It can only be converted from one form to another, or transferred from one object to another. Okay. If I have a bottle on my desk and I push it over, I am transferring the energy that I have in my body that I got from the chemicals that I've eaten, and they've been converted into work that my cells can do, and I'm transferring to that bottle that is just sitting on the desk, and therefore, because it's on the desk, it has that potential, gravitational potential energy, and when I push it down, that transfer of energy from my body to the bottle will make the bottle fall down. It'll make it do work, okay? And so again, so since we have work is equal to change in energy, okay, we can also say since we're dealing with a change in energy, then we can say that the potential energy of an object raised above ground, for example, is equal to the amount of kinetic energy that that object will have when it falls down. Okay, so I'm going to make a little note here. So the energy possessed by I give you the example of the bottle. Raised above ground. So here we have gravitational potential energy is equal to the energy possessed by the bottle when it falls. And so that becomes then energy of motion, and so that becomes kinetic energy. As it's falling, we have kinetic energy. And so that's why we're dealing with a change in energy. Okay, so change in energy, or a delta E. All right. Now, we're going to look at both EP and EK, potential energy and kinetic energy, separate. And for potential energy, we're going to focus on gravitational potential energy. In Physics 20, you're going to see elastic as well, but we're going to look at this one for Science 10. Okay. So gravitational potential energy, again, we're going to have an object that has potential energy just because it's been lifted a vertical distance, just because it is off of the ground. Okay, so there had to be some work that had to be done in order to get that bottle, that object, to have potential energy. Okay, so let's say this is work done to lift an object a vertical distance. Okay. So in order to find the EP, that object has, we must find how much work it was done, or how much work it took to get it there. Okay. So let's say that I have, a chair sitting on the ground. I can figure out, well, how much energy, how much work is sort of the ground doing to keep that chair away from gravity, right? So EP is going to be equal, again, it's energy. Therefore, we said that energy is equal to work, and it doesn't matter what kind of energy. So EP is equal to work. Okay. Now work, we did it last time. We said the formula for work was a force times a distance. And then a force, again, we did that last time, is mass times acceleration. But this time we're dealing with gravity. And so the acceleration due to gravity which if you remember it was called G, was 9.81 meters per second squared. All right. So if I were to combine all of these, I could say that EP is equal to, okay, force is mass times acceleration, so mg, and what am I left with? I'm left with d. But in this case, because I'm dealing again with above ground, because the object is standing above ground, instead of distance, is going to be replaced by height, because I'm standing above ground. And so the formula for potential energy is going to be EP is equal to mgh, where EP is the potential energy, and again, since it's energy, it's going to be in joules. M is the mass in kilograms. G is the acceleration due to gravity. Which is 9.81 meters per second squared. So in this case, I'm not just putting the units, I'm also putting the number because it's a constant. It's always the same. And then h is my height. And just like distance, we're going to measure that in meters. Okay, so that's the formula for the potential energy. Let's see how we approach a question with EP. So let's say example 1. A 5.0 kilogram hammer is placed on a counter 2.0 meters high. What is the potential energy of the hammer? So that's what I'm looking for. I have my M, I have my G, and I have my H. Just plug those numbers in. I'm actually I'll put the units in here so you can see. Kilograms, 9.81 meters per second squared. And I have 2.0 meters, just to have all the units in there. And my answer here is going to be 98 joules. Okay, so I want two significant digits for the answers. That's going to be 98 joules. Okay, so let's try example 2. And again, I'm going to remind you to try these on your own before you proceed, so you can stop the video and then continue. So Trent weighs 600 Newton. He climbs up a 3.5 meter ladder. What is Trent's potential energy? So remember, that weight is a force, is mass times your acceleration due to gravity, right? So it's a force. And so then what I do have, when I look at my EP formula, by having Trent's weight, what I have is I have these first two. I have the M and the G. And so then mg is 600 newtons, and then h is what I'm left with, is 3.5 meters. And I end up with 2100 joules. And so again, you can divide this by 1,000 and get 2.1 kilojoules, because we need 2 significant digits, or 2.1 times 10 to the 3 joules. Let's see a question where we have to manipulate our formula. So example 3. So this time we're going to start with the AP. So we have a crane uses 8.00 kilojoules of energy to lift a beam onto a building. Onto a building. And we want to know if the beam weighs 125 kilograms. Oops. How high is the building? Okay. So again, we can write down our variables and we can say, okay, so my EP is 8,000 joules, because I have it in kilojoules, so don't forget that. So then I have 8,000 joules. And then I have the mass of the beam, 125 kilograms. I have G, 9.81 meters per second squared. And I also have, I'm looking for my H. So EP is equal to mgh. I need to find H, and therefore I gotta get rid of M and I gotta get rid of G. Whatever I do to one side, I have to do to the other. And so my formula becomes EP divided by mg. That's going to give me H. And so 8,000 joules divided by 125 divided by 9.81. And the answer to 3 significant digits is 6.52 meters. That's how tall our building is. Not very tall, but okay. So this is potential energy. I'm going to also attach some questions with potential energy, as well as the key for the worksheet that you guys got the other day. And then on Monday, we're going to go through kinetic energy. We're going to look at kinetic energy formulas and see how these two relate to one another. All right, so practice those sheets, and then on Thursday, I will put up the key for the potential energy worksheet as well for you guys. And then we will see each other tomorrow. So if you have any questions, you can ask me at the Google Meet. Okay, bye-bye.